seconds. Yeah, we are live on YouTube now.
Okay. Hi, a very good evening and welcome to all of you in the virtual platform of Association of Indian Primatologists. Today, we are going to have our sixth online talk series in AIP talk series. And today our guest is Professor Anindya Sinha, who is popularly known as Rana. He is the professor in National Institute of Advanced Studies. He is also associated with Center for Neuroscience IISc Bangalore and also a founding faculty member in MSc Wildlife course NCBS. Apart from that, what we know about Rana is more than 20 years he is working with Bonnet Macaques, and I think it is his 20th anniversary where he is working, 20 years continuously for long term with the bonnet population. His works and research interests varied broadly. He worked macaque cognition, evolution, conservation, as well as he also worked on the evolution of songs and music. Although his early research concerned to molecular biochemistry of yeast, social biology of wasps, population genetics of elephants, and the classic genetics of human disease, his principal interest over the last 3 decades have generally been in the behavioral ecology, cognitive ecology, population, and behavioral genetics, evolutionary biology, and conservation studies of primates and other mammalian species. He is also deeply interested in natural philosophies, performance studies, and in the tangible and intangible culture heritage of India, especially concerning human non-human relations and the lived experience of other than humans. His current obsession is to specify, understand what living in urbanizing habitat might mean to non-human individual and population, and reflect on the opportunities that ethnographies rather than ethological explores for our understanding of more than human life worlds today and in future. So welcome Ranada. Now the stage is yours.
Thank you very much, Orijit. Am I audible? Is this fine?
Yes.
Yeah. All right. Thank you once again, the Association of Indian Primatologists, for inviting me to give a talk. It's wonderful to be here, and I must say that it's a very new experience talking in an empty room. But I know you're out there listening to me, and I hope at the end of this talk we'll have some interesting discussions. I have been working, of course, on a variety of issues, and as Orijit mentioned, I've been studying bonnet macaques. I've been living with bonnet macaques now actually for almost 28 years, Orijit, a little more than 2 decades. But let me go into the talk first, and let me begin with a quote from an individual who I've always admired, whose writings I've admired. His name is Malcolm de Chazal, and he's very little known. He was a French humorist who was born and died on the island of Mauritius. And this is what he had to say about monkeys. He said that monkeys are superior to men in this: when a monkey looks into the mirror, he sees a monkey. And with that line, let me go straight into what I want to talk about today, which is trying to understand and to share with you some of our understandings on social cognition in wild bonnet macaques. Now, my own work has actually spanned various levels of organization of primates, beginning from communities, going down to single species, populations and their variation within a species, societies that form within these populations. And of course, if you don't have individuals, if you don't understand individuals, you don't understand the formation of these societies. But then when an individual lives within a society or a population or a community, it of course takes certain decisions, and the mind comes into play. And it's very interesting how I began my work in primatology, beginning with the mind, because social cognition was my first love, and which is why when Orijit asked me to speak today, I thought I will talk about minds. But then I realized that over the last 2 or more decades that I've been working with them, my work gradually sort of spread to take over different levels of organization. And today, the take-home lesson that I have from all these studies is that if you want to understand a society or an individual, you have to look at various levels of organizations. So if I need to understand the mind, I need to understand the community. And if I need to understand the community, I will possibly need to understand the mind as well. But today's talk, of course, is basically on social cognition, and therefore I will focus on the mind of the macaque. Now, why did I get interested in studying the primate mind? And I think there are a series of questions that I have put down here. And I think each member of the audience will look at the primate mind perhaps differently from the point of view of where their interests lie. The first and the most important question, and that's the one that drives me even today, is there any way of knowing what it is like to be a monkey, right? And uh, it's philosophically perhaps impossible, but I would like to think that through our empirical studies, we may get just about a glimpse of what it might be like to be a monkey. The second question is that of evolution. How did we come to be what we are today? I think for humans, the mind is a given. There are enormous capacities that we have, and I think it's important to recognize that with these capacities, we are able to perform a huge amount of tasks, both within our societies and within ourselves as well. And therefore, the question is, if we can understand how we are taking these decisions, do we know the mechanisms? And therefore, do we understand the brain, the primate brain, to see how much of these decisions are being made using cognitive principles? And finally, stepping out of the individual, will our knowledge of the primate mind really influence the way we relate to them? You have most probably heard of the Great Ape Project, in which people are now arguing that since the cognitive abilities of a fully adult chimpanzee is comparable to, let's say, a 4 or a 5-year-old child, if we decide not to do experiments on a human child of that age, are we justified in doing experiments with chimpanzees? And that's basically the Great Ape Project. And I think, therefore, our understanding of how the mind works in other non-human species will perhaps determine how we relate to them, how we treat them, and how we exploit them, and whether there are steps that we need to take backwards and decide ethically and morally how we should deal with them. Right. Now, the complexity, to come down straight to social relationships, the complexity of social relationship in a primate society, and that includes humans, comes actually from 2 levels. One is the level of the individual, because each individual has a very rich repertoire of communicative behaviors, which allows itself to be expressed, and it allows such an individual to develop complex relationships. But there may also be complexities that come from the level of the society, because each primate society has individuals of different ages, sexes, dominance ranks, kinship, all of who live together. And within the relationships that develop, you also have subgroups or alliances or long-term relationships that may cut across these biologically defining categories. And hence, when you deal with a complex society in which you are yourself embedded, in evolutionary terms, you see 2 very direct impacts of this complexity. The first is, and you can think about this in terms of your own life itself, you always have a complex network of associations and interactions where you have many alternative strategies for survival or reproduction. So, and I of course talk of survival and reproduction because these are the two most important currencies for evolution. So when you're at home, you behave in certain ways with the individuals who are at home, and then you step out into maybe an educational institution where you study, or you go to another institution where you work, or maybe you sit at a pub drinking beer with your friends. And so you're embedded within any point of time in a very complex network of associations. And remember that each of those relationships that you have in those networks is unique. And therefore, depending on where you find yourself, you have many alternative ways of expressing yourselves, or many kind of decisions you take. Now, this is over space, but you also realize that being a long-lived individual, there is over time a number of different roles that an individual can play, and a number of different strategies that an individual can adopt over their lifetime. So when I was a child and I lived with my parents, there were certain codes of conduct that I followed, and there were certain things I could do and I couldn't do. And then I went to school and I went to college and university, and then I had my group of friends. And then at some point I got married. So I had a spouse, and then I had children. And then maybe one day I'll have grandchildren, and heaven forbid, if I have to live with my children and my grandchildren, then it will be extremely demanding. And I will therefore have to change my strategies of survival under those circumstances. I will most probably be post-reproductive at that point of time. But the world that I will have as an elderly individual, either in an old age home or with my children, heaven forbid, will be very different from the world that I had when I was with my parents as a child. And therefore, you see that how complex these relationships are, how they change over time, and gives you a whole range of choices to choose from of how you should behave in those complexes. Now, if we want to study the evolution of the primate mind, there are various driving factors which could be important. And here, I'm not going to go into a detailed discussion of various hypotheses that have been put forward. So, for example, some authors believe that harvesting of food resources, agriculture, and beginning from, of course, hunting and gathering, put enough cognitive pressures on us to be able to function. And today we are able to establish huge cities because we have been able to understand what those food sources are. There's a second school of thought which talks of tools and how tools may have forced us to think of ways of solving problems. However, a third group of hypotheses deals with society. And as I told you, that we live in very complex societies. And if you actually step back and think as a human being, what is it that you do the whole day? Where do you spend most of your cognitive time in? I can bet that for most of us, it is in social relationships. And therefore, clearly, the social complexity of our lives may have put enormous pressure um, on us, on our cognitive abilities. But let me tell you that all that I mentioned, whether it's food or tools or society, they are not mutually exclusive. They may have all played a role in the evolution of our intellect. A second point that you must remember is that this is a spiral. So because we live in a complex society, I have to take certain decisions, and therefore there was perhaps natural selection for certain kinds of cognitive abilities. But then when cognitive abilities evolve in your relatives or in your adversaries as well, that puts again pressure on you to understand how to go up beyond that. And therefore this is more like a spiral, a kind of an evolutionary arms race where intellectual abilities most probably underwent natural selection and arose in more and more as you had to solve more and more complex problems. Another advantage of actually this school of thought of looking at social complexity is that if you do comparative studies across a whole range of primate taxa, you might be able to find correlations, as has been done by a number of people, including, let's say, um, Robin Dunbar, who started off the whole process, but subsequently a whole range of people who found that as social complexity increases, and social complexity can increase and you can measure the increase of social complexity by group size, by the number of individuals you interact with, or the repertoires of behaviors that you have to interact with them. And we are not getting into the details of how you define social complexity. Do you see a correlation with cognitive abilities? So in other words, has social complexity actually selected for enhanced cognitive abilities? And once we get into non-human species, an important question then becomes, can certain higher cognitive attributes be defined functionally in non-verbalizing primates? Now, so hopefully I've been able to establish that the advantage of looking at the social forces driving cognition is that we are able to do comparative studies, but we are still left with an extremely important problem, that we cannot talk to the non-human species that we are studying. Uh, does Orijit have a mind? Is he thinking? Of course he is. And how do I know? Because he told me just a little while ago what he thought about my talk. The macaque, unfortunately, cannot tell me. And therefore, I have to define functionally certain attributes of these individuals, which will tell me about their cognition. And therefore, if I need to speculate on the higher cognitive processes in wild primates, I would need to understand what are the behavioral correlates. What behaviors should I study that will tell me about the cognitive abilities of these primates, right? An extremely important question in cognitive philosophy is that a lot of the reasoning and abstractions that a human is able to do is facilitated by her language. Now, clearly, there is no complex language of the kind humans have in any other species. I have said complex language because we are now detecting largely semantics, but perhaps some elements of syntax in other non-human communication as well. But leave aside that, the kind of complexity our language as a species has is unparalleled. The question then is that since the other non-human species do not have a complex language, are they capable of reasoning? Are they capable of abstract thought? How far is this limited by their lack of a knowledge, by their lack of a language? This is an important point, but again, I won't go too much into the details of it. And finally, there is, of course, this holy grail for some of us. What about consciousness? You can define consciousness in various ways. And the question then is, are non-human primates perceptually conscious? Are they reflectively conscious? And I'm not going into the details of these, but perhaps during discussion, if any of you are interested, we will get into that. Please remember that when I began my work 20 years ago, or 25 years ago, if I used that word consciousness in any of my papers, it would be rejected right away. Today, we are in a very, very different situation. Today, I can legitimately talk about consciousness, how we study them in non-humans, and try and see whether we can look at different manifestations of consciousness to try and establish again whether they are conscious, perhaps in different ways from us. But that's, again, a very different story. So let me not go there right now. Let me get into the meat of my talk by first looking at for some evidence of whether social complexity indeed may have selected for enhanced cognitive abilities. And before I get into that, let me first talk about one of the philosophical foundations, and this is only one of them. This is not exclusive. There may be other sort of takeoffs from this, but I spent the earlier part of my cognitive research in really looking at the theory of mind. And much of my work is based on this foundation. So let me talk a bit about it. Now, if any of you study animals, and it could be even a domestic dog at home, or it could be a macaque or an elephant or a whale, you will see that when you look at social interactions between them, many individuals seem to know and predict each other's behavior, right? And even we do it, right? Even if I meet an individual on the street whom I don't know, I'm sometimes able to predict what that individual would do in certain ways. However, a more important question is, are non-humans as knowledgeable about others' beliefs, emotions, and intentions? So in other ways, in other words, what I'm trying to say is that while we are able to predict each other's behaviors, how much of this prediction actually depends on our ability to read others' minds, their beliefs, their emotions, or what they would like to do. And in 1978, David Primack and Woodruff came up with a very interesting paper, which is called Does the Chimpanzee Have a Theory of Mind?, in which they actually tried to understand what is it to have a theory of a mind, right? And the question, the way they defined it is to say that if you have the ability to attribute a belief, some knowledge, an emotion, or a memory, or a desire, or any of these attributes, if you're able to attribute that to yourself or to others, then you have a theory of mind, right? And what they went on to say is that if you have such a theory of mind, then you're able to recognize certain specific mental states in yourself and in others. I'm very excited to give this talk, believe me. And I know that some of you might already be thinking, oh, this is boring. I didn't think this would be that boring. Maybe I should just leave, right? So you clearly are able to reflect, because then you say, oh, but then when Rana asks me tomorrow, did I like the talk? What am I going to tell him? So what are you doing? You're basically reflecting on your own thoughts. So you are recognizing a specific mental state in you. You are recognizing a specific mental state in me. And that, of course, means that you have a theory of mind. Right. Now, one thing that I've quickly done in this, and of course, as you know, for every biologist, the definition of a problem is very important. And a lot of people ask me when I tell them that I study the mind, they'd say, what is the mind? And really, there are very, very complex, perhaps, definitions of the mind. And again, I don't have time to go into them now. But if you look at it here, if you look at Primack and Woodruff, the moment they said that if you can recognize a particular mental state, boredom, excitement, desire, whatever, a memory that you recognize a mental state. And if you have a mental state that you can recognize, you have a mind. So in some sense, this might be a very basic definition of the mind, but it works. And so now the question then comes up is that when an animal is able to predict another animal's behavior, is it really reading behavior, or is it predicting motives or beliefs? And if you look at this a little more closely, you will see that if you have to predict behavior, you go through trial and error mechanisms. When you cross a road, you look left and right. Why? Because you know, you have learned through trial and error that if you don't look left and right when you cross the road, you can be hit by a car. So therefore, when you're crossing the road, you are predicting the behavior of the car. That is a trial and error mechanism that helped you learn, and you're able to predict the behavior. However, if you look at motives or beliefs, you could say, you know, I'm going to cross the road, and even if I forget to look, the lady who's driving that car will most probably not hit me. So you know that you're now attributing a motive or belief not to the car, but to the person who's driving the car. And that is a knowledge-based system. And then you say, oh, there's another professor of NIAS who's driving, and he's very likely to kill me. So therefore now that knowledge of how the car will behave because of the driver is truly a prediction of a motive or a belief, right? And of course, one thing you must remember is that though I have presented them as two extremes, there is a continuum. How do I read the motivation or a belief in another individual? Clearly by looking at behavior, right? So if I see you rolling up your sleeves and really snarling, I know very well what the next step of your behavioral action will be, right? And that I read from your behavior. You haven't really told me what you're going to do to me. So clearly it's a continuum, but for the practices, just for the sake of argument, you can look at some things that are very mechanically learned through trial and error, which we call prediction of behavior. And at the other end, there can be very, very subtle decisions that you take on the basis of predicting the motivations of other individuals, which would be at the other end of the spectrum. And we clearly lie, if you look at the entire gamut of behaviors and behavioral decision-making, somewhere in between. Right. I'm sorry. So now there are three sort of important factors I just wanted to, or phenomena that I just wanted to touch upon as I move on. The first, of course, as I said, that what I call mentalism, this ability to read your own mind or those of others, is of course, and I've already talked about this, it is explicit behavioral experience, right? You learn by reading behavior. Ultimately, you learn how to read the mind by through your behavioral experiences. The second is, of course, a very important factor, which has been suggested to be one of the important reasons why consciousness perhaps evolved, which is the projection of experience. If we live in a complex society where in some sense we are also competing with each other, I need to actually predict what you're going to do under certain situations if I have to do better of you. If there is only one slice of bread and I know that in this lockdown I will not get any more food, I will have to think of ways of getting to that single slice of bread without giving it to you. And for that, I will have to read your behavior. And I know that when I'm really hungry, these are my options. So is it possible then that those would be your options as well? And so I project my experience onto yours, right? A third point that I wanted to mention here was that of mental states as intervening variables. And this I will give you an example of how it works. Now, let's say there is a group of monkeys where there is A, B, C, D, E. And if you look at the upper part of the figure, you know that when I have a banana, B grabs it. When C has a banana, B follows C. Bananas are in the tree, B climbs tree. D has a banana, B grooms D. E grabs B's bananas and B threatens E, right? So if you learn these associations, of course, you'll be able to predict behavior. I know that when I have a banana, B will come and grab it. I also know that when D has a banana, B will come and groom D. So these are separate behavioral associations that each of us can learn. However, let's imagine that you have an intervening variable, which is your theory of mind, and you are able to predict right in the center that I have a feeling that the mental state of B is such that she wants bananas, right? Then I know, if once I'm able to attribute this mental state, I know that because B wants bananas, she will grab my bananas, she will climb tall trees to get bananas, she will follow others who have bananas, and she will groom those who have bananas, right? And what should I do? Once I have an ability to recognize this mental state that B wants bananas, I will be able to say, guard bananas from B, do not try to take B's bananas, give bananas to B when he or she is needed as an ally. So I offer you bananas and I take your help. So therefore, as you can see, that if you have a theory of mind, you're able to look at a large number of input behavioral variables into that mental state, and you can then generate and understand a whole range of outputs that may emerge from there. So now to come directly to my work, I looked at two, and I'm going to talk about actually just two complex behavioral processes. One is social knowledge and one is tactical deception, which tells us a bit about how the mind of the bonnet macaques moves or how certain decisions are made in these domains. Now, let me go a little quickly because I might run out of time. Now, the bonnet macaque, let me introduce you to the species. Many of you may be familiar with this. It's a cercopithecine primate, which is endemic to southern India. And usually it lives in multi-male, multi-female groups, which can vary in size from 5 to 75 individuals. Females are what are called philopatric, which means once they are born, they live in a particular area. And once they reach sexual maturities, they set up strong linear dominance hierarchies. Males, usually both juvenile and adult, tend to leave their natal troops and show emigration, but this is not invariable. Immigration, they can leave, they can come back. After many years, they can keep moving from one troop to the other, and in a number of unusual situations, they can even stay back in their natal troop and never emigrate even once. Usually males set up unstable dominance hierarchies through aggression and through coalitions, but also where it's fascinating is that bonnet macaques seem to have very unusually extensive affiliative interactions with one another, which almost parallels that of females. And finally, the society is typically promiscuous with periodic consortships, ample mating opportunities, mutual tolerance amongst males for these mating opportunities, and very, very subtle female mate choice. Now, there are two sort of take-home messages that I would like to give you. One, of course, is that if you read through all that I have written here, you will see usually, generally, not invariable, permanent or transient, unstable, unusually, typically. What does it tell you? It tells you that I really question whether there are ever any typically species typical traits, especially in social behavior. I think it is time to move away from species generalizations and really look at populations, really try and understand individuals, because the variability that you have amongst them is huge. And maybe at the discussion time, we will bring about why my philosophy has completely moved away from species. And here on the right, you can see 5 males from my Bandipur troops. Of course, as you can see that they have remarkably different hairstyles. But what you will also, I would like to assure you, is they have completely different decision-making processes. They have completely different life history strategies. And today we know more than 2,000 individuals in Bandipur as individuals. No two individuals have ever been similar in any of these complex social behaviors that I'm talking about. Right. Now, I will not spend too much time on the methods, except that we studied a large number of troops in the University of Agricultural Sciences, Mudumalai, Bannerghatta, Bandipur. And the methods, of course, as many of you perhaps know, are very simple. We identify social groups, individuals, we enumerate demographic variables, and then we sample behaviors both qualitatively and quantitatively using a variety of techniques, which I can discuss with you later. Maybe we don't need to spend too much time on this. Now, one of the first, so when you want to study the primate mind or any animal mind, one of the most fertile ways of doing this is to really try and understand how an individual takes a decision, right? Because when an individual is deciding between different options, that perhaps gives you an idea of the kind of mechanisms that may drive such decision making. And typically, some of these social interactions are very complex. So let's look at one of these, which I studied. Now, let's imagine that there are 3 females in a group, A, B, C, and A, B, C can be any 3 females in the group as long as A is dominant to B and C, and B is dominant to C. C is therefore subordinate to both A and B, right? And in one particular interaction that I saw, B and C, who are both subordinate to A, are sitting and grooming each other when they suddenly see a female dominant to them, approaching them, right? And one of the decisions, I will talk of other decisions, but one of the decisions they take is that B or C leaves even before A can reach them. And what we found was that in about 85% of the instances where we saw who left, it was C, the most subordinate individual who left. But in 15% of the cases, it was the intermediate individual, B, who actually left. And the simple hypothesis that I sort of generated here was that subordinate females prefer to avoid 2 higher ranking individuals during allogrooming supplants. C says, oh, I'm sitting with B who's dominant to me, and A is coming along and she's dominant to me too, and I can't bear 2 dominant females here, I better leave. But then that's a general decision she takes, because in 15% of the cases, you find it's actually B who leaves. And the simple question I asked is, why then did the dominant member of the grooming dyad, which is B, why did she retreat in these 15% of the cases? Now, let me tell you that when I began this work, I had seen a few papers which had in passing mentioned the same kind of decision in other species, for example, in vervet monkeys, in savanna baboons. But all the authors who had seen them somehow felt that it was not important. Uh, it's perhaps just an exception. I may have made a mistake in noticing it. So let's not talk about it. And that's my other take-home lesson to many of you. And that is, biology, as Stephen Jay Gould also tells us, is really the science of diversity. It's really the science of variance. And I think if we chase the means, if we change the rules, the laws, only look at averages because we're trying to find what is the general principle, that's great in physics, but I don't think it works so well in biology. I think as Stephen Jay Gould said again, it is really the variability that you see across individuals, across groups, across populations. That is where the stuff of biology really lies. And therefore, I would never, ever tell you to find the general rule. I would always tell you, why is it that that exceptional individual is doing something different? Let's try and find that out. And that's where you will perhaps discover the most exciting things that at least I've ever seen. Right. And now I'm going to explain this. I'll go through just a little slowly, but don't worry too much about it. Basically, I looked at a huge number of rationales why B should leave in those 15% of the cases. And finally, what I found was this. And this is what I've plotted here. I've plotted on the x-axis of this graph what I call the social attractiveness. It is an index which is basically 1 by coefficient of variation, 1 by CV of the grooming received by a particular individual, right? Now, if I'm an individual who receives very high levels of grooming from a more uniformly across all the other individuals in the group, then I'm a very socially attractive individual. So when I take 1 by CV of the grooming received, it means basically if I have very high levels of mean, and if the variance comes down, so when I'm getting groomed uniformly by everyone, my social attractiveness index goes up. And what I found was that if you plotted the social attractiveness of C, the most subordinate female in that group, in that interaction on the x-axis, and on the y-axis, the proportion of times C does not go, but B goes, you find a correlation. So what does it tell you? It tells you that when C is a very socially attractive individual, and that definition is not coming in from these interactions. It's independently, you can collect data and see over, let's say 3 years, which was the case here, how many times have C been groomed by other members, other females in the group. You find that whenever C is a very socially attractive female, B, though dominant to her, will tend to leave. Right. Now, so that told me, and I'm sorry, let me go back. It tells you, therefore, that B, if she was taking a decision of leaving, somehow seemed to know the social attractiveness of C. Right. Now, this told me again, therefore, that there was perhaps some knowledge of allogrooming relationships that each individual female had of the others. Right. Let me now look at dominance ranks, because the dominance hierarchy is clearly an extremely important guiding principle in the lives of all primates, which includes humans as well. And what we found was, if I plot now the social attractiveness not of C, but of all the cases of B, right? And I plot it on the x-axis, and I look at the proportions of time A approached this pair when B was present, you find a very strong positive correlation. What does that mean? It seems to indicate, therefore, that when B, which is the more dominant of the two individuals who are sitting and grooming, was more and more socially attractive, these tended to be approached. This is not about retreating. This is about approaching. So whenever B is a very socially attractive animal, one female A tended to approach them significantly more. This therefore told me that clearly if A is taking a decision to approach a socially attractive individual, she usually goes by the social attractiveness of B. Needless to say, if you plot the social attractiveness of C on the x-axis, this relationship falls. But I'll talk about that a little more. There are other behavioral decisions that A could take. Once A approaches B and C, and now let's assume that nobody has gone, B and C are still there, A could do one of two things. She could either come and groom one of them, and what we found was that in an overwhelmingly majority of the cases, A groomed B, not C. And the second thing she did was sometimes she would come and show aggression. And whenever she showed aggression, it was always directed towards C, the more subordinate of those two individuals. And all of this taken together, the previous data that I showed you and these two seem to tell you that when A approaches B and C who was sitting there, she seems to be aware of the relative dominance ranks between B and C, because if she shows aggression, she'll show it to C. If she shows allo-grooming, she will show it to B. So clearly, she seemed to know the relative dominance ranks of the two individuals she was approaching, the relationship between them, not with her necessarily, but between the two of them. Right. So what I did, and I wanted to show this a little more rigorously, and so I did what is called a logistic regression analysis, where you have a series of independent variables which can take on the form of any form. It could be categorical, it could be continuous, but the dependent variable is usually 1 or 0. And what I looked at here is the probability of retreat by any individual female. When A approaches B or C, either B goes or C goes. So I can look at the probability of retreat of B, or I could look at the probability of retreat of C. And the independent variables that I took was the individual's own dominance rank, which is, okay, let's look at B. In those 15% of the cases when B left, what is the B's own absolute dominance rank? What is the rank of the approaching dominant female, that is of A? Or I can look at the rank difference between A and B, right? I can look at the rank of the allo-grooming companion, or C, the absolute rank of C, or I could look at the rank difference with C, between B and C. I can look at the individual, that is B's own social attractiveness. I can also look at the difference in attractiveness with C. So am I more social attractive than her or less, and to what extent, right? And I ran my models using this dependent variable. These independent variables, of course, you will see that when I looked at rank of the approaching dominant female, either I took the absolute rank or I took the rank difference, because they are both different ways of looking at the same variable. And to cut a very long story short, this is what I found. I found that the probability that B, who's the dominant member of the dyad, would retreat when approached by A, and she's sitting with C, remember, the probability that she would leave increased simultaneously with her own absolute decreasing dominance rank, the decreasing rank difference with the approaching individual, and the increasing rank difference with the subordinate member of the dyad. What does it mean? It means that as B became more and more subordinate in the overall hierarchy, she was more likely to go. As A became very close in rank to B, she's still dominant, but closer in rank, B was more likely to go. And as C became more and more subordinate to her, so remember, C, when she becomes more subordinate to her, B tended to go. So here's a very complex sort of decision that B was taking, and all these three factors seem to play a role. If you dropped any of these parameters, you could not predict B's probability of retreat. What was interesting is that the probability of a retreat did not depend on the absolute dominance ranks of A or C. It also did not depend on the social attractiveness. Remember, I also put in social attractiveness, but in none of the models did social attractiveness come up, although initially social attractiveness seemed to have been driving this behavior. So what do I conclude from this? The first thing that I conclude from this is that bonnet macaque females appear to know their own dominance ranks and those of the other females relative to their own positions in the rank hierarchy. So not only do I know who I'm dominant to, but I also know the relative dominance ranks of the other females that I am approaching in that particular case. And therefore, our knowledge seems to be based on a kind of where you fit into that hierarchy. So knowledge is egotistical. So I know B may be a few ranks below me, but C is even more subordinate to me. So that's the kind of relative positions in the hierarchy that a female seems to know. Second, when interacting with multiple individuals, the social decision that an individual makes seems to be made on the basis of integrated information. In other words, it's not just one factor, it's How subordinate am I, or how dominant am I in the hierarchy? What is my rank difference with A who's approaching me? What is my difference in rank with C? And mind you, they work in opposite directions. As the rank difference with A becomes less and less, I'm more likely to go. As the rank difference with C becomes more and more, I'm likely to go. And the reason for this, of course, is that in this troop, at least, as an individual became more and more subordinate in the hierarchy, she was also more and more socially attractive. So therefore, there's a loose correlation, not quantitative, a loose correlation between dominance rank and social attractiveness. So social attractiveness was possibly was factored in through dominance rank. And that's what I speculate here, that individuals seem to know the social attractiveness of other females, but this knowledge is utilized in terms of its correlation with that of dominance ranks. What does it mean? Let's imagine again, let me go back to that old example that I'm driving a car down the road, and suddenly another individual comes and hits my car. So of course I get off the car very, very upset, and I want to have a word with this other driver. And to my horror, what I see is that the individual who gets out from the car not only rolls up his sleeves, but he also seems to take out from his pocket a little gun, which he starts polishing. So what do? I decide that enough is enough. I am getting late. I don't care whether this car has hit me. I go away. What did I do? I don't know this individual. I have no idea what he wants to do because I've not spoken to him. But by looking at his bicep size and by looking at the gun in his pocket, I have come to this knowledge that he doesn't mean the best for me, right? And under these circumstances, it may be better for me to leave, right? So therefore, from this, you can conclude that individual macaques appear to have experiential knowledge of the social attractiveness of other individuals. They don't seem to remember specific pairwise affiliative relationships. They are also knowledgeable about their own positions in the dominance hierarchy and the relative dominance ranks of the other troop members, all of which means that individuals are able to abstract and mentally represent the personal attributes of themselves as well as those of other individuals. Clearly, they have some concept of dominance, subordination, and they're able to mentally represent that because they're able to take decisions on the basis of whatever they have acquired, that information that they've acquired, and which they have somehow stored in their brains. Right? And during triadic interactions, remember, it's very interesting that B leaves because most probably she argues to herself that when A is approaching me and I'm sitting with C, when C is very socially attractive, I better go because A must be approaching C. On the other hand, when she herself is A, she must have approached the other B and C. And who did she allogroom? She allogroomed B, not C. She went by the social attractiveness of B. And therefore, it seems that here there was an attribution of motives to other individuals. There is a valid belief system that A must be targeting C, and therefore I better go. However, there was also a failure to project one's own experience on others. The argument is like this. When I was A and I approached two females, I went by the social attractiveness of B. So when I'm now B, I should recognize that if I'm socially attractive, I can stay, but I don't. I go by the social attractiveness of C, and whenever C's social attractiveness goes up, I decide to leave. So in some sense, it's a failure to project whatever you have learned onto others. And again, I can bring this up during discussion, but in laboratory experiments with rhesus macaques, it has been shown that when you look at cooperative tasks and you exchange individuals in the roles that they play in these cooperative tasks, chimpanzees are able to abstract knowledge, and they seem to know that when I was that individual, this is what I was asked to do. So when I'm now this individual, I can predict what that individual will do. This kind of role taking is not possible in the macaques. And what the rhesus macaque does is that he or she solves the problem by learning afresh what he or she is expected to do when she's the other partner in the cooperative task. And this is a brute force method. But let me tell you what's fascinating. is that on every occasion, every test, the rhesus macaque solves the problem much faster than the chimpanzee does. But let's talk about that during the discussion. There are several important problems. So one is, of course, that of acquisition of knowledge through experience. So what we showed is that when you look at the social attractiveness, or you look at the allogrooming that gets exchanged between these individuals, it's always the duration, the time spent in allogrooming that is important, not the frequency with which it's done. So in other words, therefore, it seems that it's easier for you to evaluate duration than frequency. And that's very obvious, right? So whenever you look at me, if you see I'm talking, then you get a rough idea that much of the time that I look at Rana, he's talking. However, if you have to look at the frequency with which I talk, you have to see how many times I'm talking and divide that over the overall time that you've watched me. And that becomes much more complex, right? And therefore, cognitively, it's much more demanding to measure frequency, but duration is easy. Oh, whenever I look at Rana, he's talking to someone. So he's a socially attractive individual. Let us say that's where you look at it. The second interesting problem is, what are the mechanisms that underlie the assessment of individual ranks, right? We don't know. How is it that individuals are acquiring this knowledge? How are they storing it? Now, one possibility is that there could be inference of linear orders by memorizing all the dyadic interactions, or there could be some kind of abstraction which is called associative transitivity, where I know that if A is dominant to B and B is dominant to C, then A must be dominant to C, and I'm therefore able to sequentially order these individuals on the basis of the kind of interactions I've seen between each pairs. And we don't really know what the macaque is doing in this particular case. Is there really a capacity for true deductive inference of social transitivity? People have done some experiments with food containers, amounts of food, but it's of course difficult to do experiments of this kind, and therefore there have not been any attempts to try and see how individuals are actually arranging others in the hierarchy. The next problem is that of the nature of mental representation. How do they actually represent the information that they acquire? What is dominance? And here is where language becomes important. If I tell you an individual is dominant, you know exactly what that individual is doing, right? Or what I mean about that individual, or subordination, right? However, these are abstract categories. In the how do macaques actually sort these out? And is there a, what I call a mechanism of visual behavior matching? Let me give you an example. Suppose you're walking down the road with me, and I point to two individuals who are also walking, and I say, what do you think is the relationship between them? And you would say, oh, I really don't know, because I don't know them at all. I'd say, okay, why don't you take a guess? And you'd say, you know, looking at them from a distance and seeing how they interact with each other, it's possible that they could be married to each other. How did you know that? Of course, you have a concept of marriage, but that's different. How do you acquire it? Because you've seen certain behaviors between these two individuals that matches with the template that you have of what a typically married couple will do, and you're able to match that, and that perhaps tells you that this may be the nature of the relationship. That is what I'm called visual behavior matching. And so therefore, if I see somebody smack someone on the nose, accordingly, I know this is dominant, this is subordination, even if I don't have the words to actually classify them. And that therefore tells you that there is an extremely important role language plays in our lives. Of course, we communicate with each other through language. There's no doubt about it. But imagine, even if you were sitting in an empty room and you said husband, or you said wife, or you said friend, or you said dominance, or you said subordination, there will be a whole world that will open up in front of you. All of it may be visual. And this is what I'm saying, is that perhaps the coding of information in a non-verbal species, in a species that does not have language, may be entirely visual. We have the advantage of having a label, a cognitive label that we use our language for. But in the absence of such cognitive labels, in the case of the macaque, they will most probably have to depend on a visual matching to decipher dominance or subordination, but that's speculation. So clearly there will be a limit to how much of this kind of cognitive processing they're able to do. Now, Unfortunately, I think I've spent about 46 minutes already in this talk, and I know that I think it'll be more exciting to have discussions. So I will not talk about the second aspect of my talk, which is on tactical deception, that I thought I would, but maybe we will take that at some other time. Is that fine, Arijit?
Yeah, I think this is fine.
Yeah. So shall I just let me quickly zoom through these just to get to the conclusions, and then we can perhaps open it up for discussion, right? And I'm sorry that I couldn't talk about tactical deception. This is something that's very close to me, but maybe this will give me an opportunity to look at it again. So let me just quickly, in a minute or two, just conclude what is it that we have learned about the Bonnet Macaques from our studies on social cognition, and this is what we seem to know. First, bonnet macaques are inherently capable of solving certain very complex social problems. And I would have been happy to have told you about tactical deception, because they do solve quite a few problems, but maybe we'll discuss that another time. Sorry about this. The species may also be inherently capable of making very complex social decisions on the basis of their experiential knowledge. For example, during triadic interactions, right? They seem to know dominance ranks. They may even be able to fathom social attractiveness. And through these experiential knowledge that they acquire, they may be able to take certain complex decisions. Now, when individual macaques have comprehensive knowledge of the positions of other individuals in the dominance hierarchy relative to themselves, we unfortunately still don't have any evidence of whether they are able to rank them in a linear transitive order or form abstractions of such a hierarchy. If you remember, when I did the logistic regression model, I forgot to mention this earlier, it worked every time I looked at relative dominance rank. How dominant is A to me? How subordinate is C to me? That's when it worked. If I replace these with the absolute ranks of A and the absolute ranks of C in the hierarchy, the models did not work. And that therefore tells you that maybe, although individuals know that B knows that A is dominant to her, and by how many ranks she may be dominant, maybe relative, not quantitatively, but perhaps very dominant, less dominant. C is very subordinate or less subordinate. They may not actually be able to align them into a linear hierarchy, because if they were, then even if I substituted these values with absolute rank positions, it should have worked. But the models didn't work. Macaques may be able to form rudimentary mental representations generated by such experience of themselves, of their social companions. Such individuals may also have a limited capacity to recognize their own mental states and those of their adversaries and act upon the available differentials of their knowledge states. I know certain things that you don't know, and we may be able to take advantage of what you don't know, but I know. And this would have been very clear to you had I talked about tactical deception, right? And finally, um, uh, what we have been arguing for, and we can discuss this later, is do these insights perhaps suggest for us a very early evolutionary origin for cognitive capabilities that characterizes some kind of an objectified self in these individuals, where they have some regulatory control over more subjective levels of self-awareness. And we think that perhaps this ability arose even before that in the great apes, except that we haven't really looked at the macaques very closely. And if there is indeed such a concept of an objective self, it might involve primitive cognitive representations of themselves, allowing for self-referential behavior. Depending on what my position in the hierarchy is, I take a certain decision. So it enables individuals to use their own knowledge to model the behavior of themselves or of others, attribute motives or intentions to them. They might exhibit visual perspective taking, and I could have talked about this if I had more time, or they could influence other individuals by intervening in their behavior. Such individuals, as I pointed out, may, however, sometimes hold erroneous beliefs, and they may fail to project their own experiences while predicting the behavioral motivations of other individuals, and therefore come to theory of mind, even if bonnet macaques do have I wouldn't say a theory of mind, but perhaps a rudimentary hypothesis of the mind. It is perhaps a rather incomplete construct. And again, perhaps we can have this discussion another day where I can tell you why I think that even this hypothesis is incomplete, but that data comes actually from my work on tactical deception. Right. I wanted to end with acknowledgements. The first name, Tapan Sinha, is my father, who bought me my first moped and my first 286 computer on which I did all this work. Sudha Premnath helped me write the original programs for my data analysis. Milind Watway spoke to me about social attractiveness. We discussed this, and I think I owe it completely to Milind. Niranjan Joshi, who some of you might know from the Center for Ecological Sciences, has been my mentor right through, who has always encouraged me. Anirban actually collected quite a bit of the data on tactical deception, which I couldn't talk about, and Sartaj helped me with the analysis of that, which I couldn't talk about. There are, of course, a large number of institutions. I've only mentioned those which are directly involved in this work, who helped me in my work. And let me now return back and let me end with, if you remember what Malcolm de Chazal said, that monkeys are superior to men in this, that when a monkey looks into the mirror, he sees a monkey. But let me tell you that at the end of this 27 years of being with them, when I look into the mirror, I see a monkey as well. Thank you.
Thank you, Ranada. Thank you for the wonderful talk. Though we are very sorry about the time constraint
No,
and
no, no.
we are not
My
able
fault.
to put that tactical deception there, but we'll be very much like to go with you another session where you can talk about tactical lesson and we can tactical deception, we can discuss about it.
Sure.
But today, through
Can
your
I,
talk,
sorry, one question. Can I stop sharing the slides and get back into discussion?
yes, yes, yes.
Unless somebody is very clear, wants to see some of the data, but maybe we can come back to it if necessary.
Yes, sure, sure. So today with Ranada's talk, we are able to know about how it works on bonnet mind. Especially we always think about see this behavior, what we can see, but what are the other things, what affect them to do that kind of behavior, to go for that kind of behavior, and what are the cognitive, transfer distributed through the macaque society. We are able to know about this. And thank you very much, Ranada.
Thank you very
Now,
much.
our session is open for discussion. We already have few questions there in chat box. As you have suggested, you can,
Yes.
scroll down and you can see.
Yeah, I can see them. And shall I just go in sequence, because that may be the best? I'm not sure I'll be able to do justice to all of this, but let me just starting off. Now, Rashmi Singh asks whether there has been or can there be a comparison in the degrees of complexity between different wild primate species? And yes, very much so. And in fact, that's what I mentioned as a real powerful way in which perhaps we can examine the evolution of social cognition, is because you can set certain parameters, you can define certain parameters in social complexity, and Robin Dunbar has attempted to do this. So for example, there could be small social groups, and within small social groups, there you can look at the differences in perhaps genetic relatedness, in hierarchical differences, and then try and look at complexity measures on the basis of which of these individuals one particular individual interacts with. And therefore, then from there, you can independently look at cognitive decisions that individuals make, and then try and see overall whether there's been a correlation. And maybe I can send you some papers if you write to me independently, because there has already been some analyses that I can let you know, Rashmi. Now, Ruby asks, can you tell us a little more about perceptual and reflective consciousness? Yes, I will tell you very, very briefly, because that's really a full talk by itself. But basically, if you have a mental state, you are perceptually conscious. That's it. So if you have a state of desire, if you have a state of memory, if you have a certain intention, then you are perceptually conscious. And by that definition, one would argue that perhaps most living beings are perceptually conscious. The tough part is what is called reflective consciousness. Now, Ruby is not at all happy with my answer. And so she says, oh, I don't like this answer. She's able to think, she's able to reflect not only on my mental state and what I'm saying, but she's able to reflect on how she's responding to it as well. And that is reflective consciousness. That is what is most demanding. And a lot of philosophers believe that perhaps humans are the only truly reflective conscious species. And I completely object to that, because how do I know how Ruby responds to me? How do I know Ruby does not like what I'm saying? Because when I talk to her, she tells me. So a lot of reflective consciousness is revealed through communication. And I can give you a thought experiment if you want. You can sit with a person who you don't know. You can spend a week with that person in an apartment, not even exchanging a single uh, uh, a word with him or her. And I will then challenge you to tell me, do you know whether that individual is reflectively conscious? And I can tell you, you will not be able to tell me. The ability to recognize that somebody is reflecting on his or her own mental states requires communication. And that's a major methodological gap that we have with non-humans. So I think to that extent, we really will never know whether other non-humans are able to reflect or not. So that I will end with that. I will come back to you. Now, Nandini writes, how do you differentiate one individual bonnet from another? It's very simple. You saw those pictures, but I can tell you, if you come with me to the field and you spend 7 days with me, you will know them all. So it's really a question, and it's interesting, right? And so I had this discussion with somebody else in another webinar. Uh, um, I get very confused when I see Chinese gentlemen, right? I get very confused and I can't recognize one from the other, but I don't seem to have such a problem with members of my own community. I think the answer lies in where you're actually focusing on. And I think we learn from our childhood. When you're embedded in a society, you learn to focus on perhaps the most variable aspects of an individual's facial features, let us say. And I think for Indians, eyes are extremely variable. And so we perhaps recognize individuals by their eyes. Unfortunately or fortunately for the Chinese, eyes are perhaps the least variable of their morphological features. And so if you've learned to recognize individuals through eyes, you'll fail miserably with the Chinese. But maybe when Chinese recognize each other, they look at their ears. I don't really know what they do, but I do know a lot of my European friends have tremendous problem identifying one Indian from another. And I therefore know it just takes time for you to be there and to find out. Now, Neha asks, what is the impact of the social cognition behavior of macaques due to interaction with humans? Has it improved significantly? That's a wonderful question, but it's something that in our current work on urban ecologies where macaques and humans interact very, very regularly over the day, over years, it's fascinating to ask, how have this coexistence, this continued coexistence actually shaped each other? And social cognition, of course, is one aspect of it, but there may be other aspects of behaviors that perhaps we have learned from each other. And that's a very deep question. We don't have too much of empirical evidence. For example, we know that some macaques, rhesus macaques in Delhi, open taps and drink water, but they never close them, right? So it's very likely that they have learned perhaps by watching humans how to open the tap, but you can never rule out in the wild whether they have learned that through trial and error, right? So there are obviously limitations of how much we will finally know, but that's really an open question. And then Divya Dwivedi asks, in a species where females do not show strict hierarchy, how do these displacement data account for a dominance rank accuracy? I don't really know. And I think it's a fascinating question, but I attempted the same analysis that I did here with another troop that I was watching, that I've observed also for 3 years in the GKVK campus of Bangalore. And what's fascinating is their social attractiveness measure, the social attractiveness was not the one that operated here. It was just mean frequency or duration of allo grooming that an individual received. There was the variance did not come in at all. So whenever an individual was received very high levels of allo grooming, didn't matter from whom, B would retreat. right? So it's entirely possible, and that's tantalizing, and it's complete speculation, that maybe as you go from group to group, there may be different kinds of very, very subtle rules that seem to work, and individuals perhaps use different parameters to take certain decisions in these species. And that's a very provocative comment I'm making. We don't have evidence for it, but I think it's important to perhaps leave our mind open. Uh, right. Okay, let me see. Sorry. Okay. So then Krishna Pitwa asks how cognition behavior is different in wild troop macaques and troops living around human settlements. I think there's a lot to be said about that. We don't have enough evidence yet. However, there have been some studies, and you may be familiar with them, where people have looked at canids. They've looked at domestic dogs and compared their performance on certain tasks as in with their wild relatives, right? Perhaps species with whom they've shared ancestors. And it turns out that the domestic animals perform far, far better on many of these tasks than do their wild counterparts. And I think part of the story may lie, of course, in behavioral flexibility, where when you live in a complex environment, you tend to learn certain behaviors. That's, of course, there. But I think what the Canid story tells us is that over time, uh, perhaps there has been artificial selection for cognitive abilities. Let me tell you what I mean. So if you are a dog lover and you want to bring a pet dog home, which of the litter do you choose? Which animal from the litter do you choose? And typically people will go and choose an individual who responds, perhaps, or maybe if the human waves the hand, the dog runs to it, and you immediately select it. I think what you're doing is, like Darwin said, for pigeon fanciers, very similarly, perhaps over evolutionary time of since domestication began, we have actually artificially selected for cognitive abilities in domestic animals. And therefore, perhaps if you have uh, individual macaques which live in a city, one possibility is at the immediate behavioral flexibility level, they may be much more flexible. They may have learned through experience how to change their behaviors. But you also cannot rule out that if a macaque lineage has lived with humans for 2000 years, and I think that's what has happened, because we find the first reference to macaques in the Tamil Sangam poetry, which is about 2000 years old. You may have also had genetic selection for perhaps more sophisticated cognitive abilities that allowed individuals to live much more carefully, much more successfully with humans. Right? Two groups of macaques. Can we draw can we do comparative analysis of cognitive abilities in two groups of macaques? Yes. We haven't done it. Nobody seems to have done it. Let's go out and do it. Stromon asks how quickly are changes in dominance hierarchy incorporated into a group. Very good question. Very, very interestingly, and perhaps we'll have another discussion on this at some other point of time. But the way the dominance hierarchy is established amongst the males and amongst the females in a group of macaques, and I don't mean only bonnet macaques. This is perhaps true of a large number of macaques, though I don't know how many studies have gone on. It's fundamentally different. Uh, Males establish dominance through fights, through coalitions, through manipulations in different ways. And it's if you plotted a graph of physical strength on the x-axis with position in the hierarchy on the y-axis, you will see a bell curve, which means that young individuals are subordinate, young males are subordinate, then they slowly start rising in the hierarchy, and then they start falling again as they age and as they lose their physical strength. For females, it's cultural. So if there is a rank A, B, C, which I talked about, all of A's daughters will be subordinate to A, but dominant to B and C and their daughters. B and her daughters will be dominant to C and her daughters, but subordinate to A and her daughters. What does it mean? It means that it doesn't matter whether you have a physical infirmity, whether you're weak, whether you're blind, or whether you're lame. If you are born to a dominant mother, then you are dominant. If you're born into a Brahmin family, you're Brahmin. If you're born into a Vaishya family, you're a Vaishya. So in some sense, therefore, dominance ranks in females is culturally inherited. In males, it's biologically inherited, if I may use the term. Culture is, of course, also biology, but I'm not getting into that. But what is fascinating is that the culturally determined dominance ranks in females is much more stable, much stronger than the biological one, which tends to vary. So Shaney and Seifert, in their long-term study on vervet monkeys, has established that the change in the dominance hierarchy amongst females, which happens with entire matrilines, by the way, was once in 17 years. It's perhaps true for bonnet macaques as well. Very rarely do you see changes in the hierarchy amongst females. In males, it keeps changing. And why is that? Because it's cultural, it's codified, and once individuals recognize that code, they usually don't change it. And that's, again, a very fascinating question, but maybe we can talk about this another time. But therefore, there are no changes very easily in the female hierarchy, though in the male hierarchy can change. Shomrat asks how much of vocalization can affect cognitive ability as compared to simple grooming. I don't exactly know, Shomrat, what you're meaning, but are you saying that when individuals communicate with each other through vocalizations, how much of information is being passed on vis-a-vis grooming? And I don't think we can compare them, because I think these are different modalities that have evolved. But I think it's interesting, it's fascinating to look at it maybe across populations or even across species. And let me give you an example here. Bonnet macaques are generalists. They are very terrestrial. They're always on the ground. They're feeding on common food resources. They're always close to each other. And therefore, visual and tactile communication, including touch, is very, very important in them. But let's look at the more traditional troops of the lion-tailed macaque, which lives in the rainforest canopy. There, individuals are forever they're specialists, they're forever finding food. They don't have an opportunity to be with each other, because they also need to space out, because they have very specific food resources. They want to minimize competition. So where is the opportunity for them to groom each other? Where is the opportunity for them to communicate visually when they're in the canopy so far away? And a student of mine, a master's student, Rupali Raghavan, who did a master's dissertation with me almost 20 years ago from the Wildlife Institute of India, she found that the most dominant communication paradigm was auditory. And it was fascinating how, depending on the dominance ranks of the individual females, the other females would respond. So if a dominant female gave a call, many more individuals responded to her vocally than when a subordinate individual gave a call. So clearly, therefore, their hierarchy is also reflected in the vocalizations and their responses to each other. And so I think there is a huge amount of work that's there that we need to do. Okay, let's move on. Okay.
Mr. Ojha.
Shormishta Oja. Yes, please tell me about the difference between problem solving by rhesus macaques and chimpanzees. Okay. Again, I'm not going to spend too much time, but there's a lot of fascinating work which I can point out to you. Now, basically, it's this, and we see this in humans as well. When you are cognitively sophisticated, let's say a chimpanzee is, how she solves a particular task is by abstraction. So she's able to abstract certain features from the task that she has been set, which she can then generalize and use and apply that in a completely different domain, right? So this is called generalization, right? And I'm sure you know this because we all do it all the time. So that's very cognitively sophisticated. When the rhesus macaque solves the same task, unfortunately, she is not able to generalize across the situation. So what does she do? So it's like this. I think the experiment, let me tell you briefly what the experiment was. So you have two chimpanzees, A and B. A knows which of the containers with her has the food, but she is not able to access it. Individual B, who's at the other end, can access the food, but doesn't know which container has the food. And they are allowed one trial. Very soon, the chimpanzee A learns to point to the one that has the food, and B immediately recovers the food. Now you exchange their positions. So now who was B earlier now becomes A, and B is there. Now the new A learns immediately or immediately displays the pointing behavior, and B accesses it. So what have they done? They've basically exchanged roles, but they have been able to conceptualize what is expected of you when you've taken the other role. And you've learned that during your interaction with your cooperator. This is abstraction. The rhesus macaque fails to do this. So now when A becomes B and B becomes A, it forgets that it has to point. It learns all over again that it has to point, and only the other individual learns that only when a pointing is done should I go and get the food from there, and that also through trial and error. However, if you look at the time course of the success of these experiments, in many cases, the rhesus macaque solved the task faster than a chimpanzee did. So what that tells you is that there is a price, there is a cost to sophistication. The advantage of this cognitive sophistication is its general applicability across a variety of situations. But the price that you pay for it is that you become slow, because you're obviously rationalizing, you're thinking that which of my information that I have can be applied here. Macaques, on the other hand, are terribly fast learners. So they don't do any of this abstraction. They just learn anew from one trial what is expected of them. So this is not a very happy way of doing it, according to humans, because it's a very brute force way of learning repeatedly, trial and error of doing it, but they do it faster. And the important take-home lesson there, Shormishta, is that perhaps different species, different individuals have evolved different strategies to solve a problem. And because humans do it, or because aesthetically we think it's more complex, more sophisticated, we give it more value, I don't think necessarily nature looks at it that way. Natural selection has selected for whatever works. I don't think natural selection necessarily, unless there are energetic demands, really goes by the sophistication that we, or the aesthetics that we humans tend to give credence to. And I'll quickly tell you one example in humans: mathematical problem solving. Now, I don't know whether you know, you are all very young, I think, but there was this remarkable individual called Shakuntala Devi, who died a few years ago, who was able to solve problems remarkably quickly, mathematical problems. What she was actually doing, and there's a paper in Proceedings of the Royal Society on this, not on her, but on this ability, which shows that people, and maybe Ramanujam, Srinivasan Ramanujam may have been a part of this, is when they solve problems, they do it in the subconscious. So they are very, very quick. But if you ask them how they did it, they don't know, because they haven't brought it into the conscious domain. On the other hand, those who bring a problem into the conscious domain are able to generalize across situations, but they do it much more slowly. So a slow mathematician is one who perhaps brings mathematical operations into the conscious domain. Those who do it in the subconscious domain do it much more rapidly, but they have no idea how they've solved it. And, you know, Shakuntala Devi used to say, I don't know how I've done it, but I have done it. And Ramanujan very famously said, I don't know the proof. The goddess of Namakkal told me the answer. And I think that's a very beautiful way in which perhaps it summarizes this kind of different ways of in which you could cognitively perhaps look at these problems. Okay. Okay, so Prerana asks me, did you study in primates' minds, help you understand human minds as well? Well, I can tell you one thing. I don't know whether I've learned more about human minds, but at least having spent time with them, I now understand myself a little more. I understand where I'm different from my macaques. I understand where I'm very similar to them. And I'm able to understand how certain decisions that they take, what are the factors that influence that decision, and how those factors differ in my case. So at least I can speak for myself. I'm sorry, I think Shubhra had a question. Shubhra Sau had a question of, can we predict plasticity in behavior by understanding social cognition? Yes, I think we can, because as you learn more and more social cognitive mechanisms, you will be able to see how individuals are able to have variability in the kind of decisions they make, which is why I said we should look at decision making as a window through which we try and understand social cognition. Oh, that reminds me, I'll come back to one point I had made earlier. Remember, I said that 85% of cases, B stays and C leaves. And the simple rule there is that A and B are both dominant to me. C decides to go. If you look at this hypothesis, it's a completely non-cognitive hypothesis, right? It's very easy for me to know that there are two individuals dominant to me and I need to go. And that may be the general rule that the macaques are following, because in 85% cases we saw it. But the reason why I today feel gratified that I decided to look at that 15% exceptional cases is because it told me about knowledge of dominance ranks. It told me about knowledge of social cognition. And therefore, it tells you that much of the decisions that the macaques may be making are on the basis of very simple rules. However, if you look at certain exceptional cases, you will see plasticity and other mechanisms play a role. Let me give you an example with the crossing of the road. Every day you and I talk, argue, and we cross the road. Both of us dutifully look left and right and we cross the road. Or I drive a car and I'm arguing with you about whether bonnet macaques have a mind. Do I even remember how many times I changed the gear or pressed the brake or the clutch? I don't. So much of this I do through trial and error, which I have learned. There is absolutely no attention, cognitive attention paid to this. But suddenly one day I tell you, you know what? It's lockdown and we are crossing the road. There is no car. Why do we look left and right? That is a rational decision. That is a decision you took because you're no longer using your trial and error method of looking left and right. You've decided to think about it. To get back to the car, driving the car, I drive every day to the office arguing with you about primate consciousness. I don't even think of how I'm driven the car. I can't even remember. But on a particular day, I tell you, wait, I have to focus on my driving because today I see a lot of very rash driving. Let's talk about this later once we reach. What am I doing? I'm now paying conscious attention to whether I should press the brake now or accelerate. And I've now therefore brought driving to my conscious domain. I'm now slower, but I'm much more sure of what I'm doing. And therefore, I think the exceptions sometimes give you windows into mechanisms that the general rule, which is evolutionarily selected normally, is simpler, but is not as exciting. But the exceptions actually give you perhaps insights into something which is different and perhaps exciting. Okay. Prakriti writes, do human minds and primate minds work similarly in times of circumstantial stress? I really don't know. It would depend on perhaps which human, which macaque. It would depend on what you're calling circumstantial stress. And one of the important problems that we seem to have in cognitive research is we tend to make these very superficial comparisons across species because we say, oh, you know, and that's what I was also doing. Though the chimpanzee and the rhesus macaque had a very similar task, in many cases in real life, we find that some of these comparisons don't really work well. But let me come back to stress and the human mind. It's very fascinating that, and many of you may know about some of these genes which are responsible, which have now been shown to be responsible for addictions, right? So people who have drug addictions, alcoholism, sexual promiscuity, in some cases, are individuals who have certain genetic predispositions. And I'm again not going into the details. One of these is, for example, the serotonin uptake regulator region of the serotonin uptake gene, the protein which takes up serotonin. What is interesting is people have asked this question: why is it that some of these genes which are responsible for addiction continue to survive in populations? Why have they not been selected against? Because addiction clearly is not a very easy situation to deal with. What has been seen, and again, I can send you the paper if any of you are interested, is that if you move into completely a different situation, you find, and that is stress, you find that those who are genetically predisposed to addiction, they perform much better under conditions of stress than do individuals who don't have those alleles. right? So in other words, what we must also be open to is when we look at certain responses, which may be cognitive, but at least behavioral, and we feel that they are maladaptive, they are not really very, very adaptive. Perhaps what we forget is that there may be other situations which may have been the major driving force for selection of these alleles or these genes, where the same individuals who are not doing very well in this situation may do better under different conditions. And therefore, if Prakriti asks me, does the human mind or the primate mind work better or similarly in times of stress, it really depends on the kind of selective forces that we have undergone. What is it that I call stress? What is it that the macaque calls stress? But what is even more important is we don't need to go there. Let's look across humans. Let's look across macaques. Perhaps the definition of stress will vary from individual to individual, right? Okay, Pankuri, you've said that within a single species, there's a lot of variation amongst on various societal constructs. If this does influence cognitive abilities, then does a species level comparison between sister species and even distant species, does it give concrete enough evidence of evolution of cognition? No. Yes, in general, I know. Okay, so let me give you another example similar to the lion-tailed macaque and the bonnet macaque and their communication modes that I talked about. A very interesting example here is that of chimpanzees and gorillas. Now, you know that chimpanzees and gorillas are very, very closely related. Of course, chimpanzees are more related to us than they are to gorillas, but that's a different point. If you look at cognitive abilities in chimpanzees, you will see that it is entirely focused in the social domain. So chimpanzees are remarkable social manipulators. You must have all read about Franz de Waal and other people's work who have actually looked at these abilities. But let's go to the gorillas. And if you wanted to look at the gorilla as a great ape, you find they have such simple sociality, such simple social rules that it's quite remarkable how they don't seem to be sophisticated at all in terms of their social decisions. And that's because the gorilla, and this is Dick Burns' work, Richard Burns showed that if you looked at all the gorillas that he had studied, they had some 98 ways in which they could process food material, which the chimpanzee would never do, because the chimpanzees are much greater generalists. So I think in that sense, what comparisons do is they may tell you across species what have been the major evolutionary driving forces. But if you want to really measure cognitive abilities, then it doesn't make sense to look across species because their cognitive abilities have been selected under different domains. So the bonnet macaque is the chimpanzee of the macaque world. The lion-tailed macaque is the gorilla of the macaque world. So the lion-tailed macaque is wonderful with food processing, with tools that it uses. Bonnet macaques typically don't use tools in as far as food processing goes, but they are remarkably good in manipulating others and showing deception with each other. So therefore, I think it's a very important point, Bakuri, that you make, that you cannot compare across species when we are really looking at the nitty-gritties of cognitive abilities. Okay. Uh, Oritro Bishwa, do I have another 2-3 minutes? I think I'm towards the end of it, I think. No, am I?
Yes, yes. Please
Okay.
take the
So
questions.
Orithro says, if we consider the most dominant male and the most dominant female, then amongst these two, who will be dominant to whom? Typically, it will be the male, simply because of the physical strength. Dominant males are able to dominate. However, let me give you an example of how they can outsmart each other, right? And so at one point in my studies, on one particular day, I found that the most dominant female in the GKVK1 troop that I was studying in Bangalore, this was way back in 1994 or 1995, I think, I found that I thought she was receptive, sexually receptive, but of course, bonnets have cryptic estrus, so you can't really make out peak receptivity. But what was happening is that the alpha male was repeatedly following the alpha female and was physically dominating her to copulate with her. But of course, she was remarkable. She kept finding ways. She would lie down, or just as the male was about to sort of ejaculate, she would zoom off. And I thought, therefore, that she was perhaps no longer receptive, which is why she was completely rejecting the alpha male. After about 15-20 minutes of trying, the alpha male gave up, didn't follow her anymore. And you won't believe what the alpha female did. she went off to one corner of the group. The group was spread, foraging. She went to the most subordinate individual, the male in the group, solicited copulation, and copulated with him continuously for 10-15 minutes before returning to the troop. So therefore, what the alpha female lost out in physical strength to the alpha male, she more than made up with her behavioral strategies by which she was able to bypass the attention of the alpha male and get what she wanted. So again, therefore, while, yes, sorry, through the simple answer is that the dominant male will sort of dominate the female, I think we need to understand behavioral strategies. I need to understand how they are successful in the things that they do in their own life from a very different perspective for different groups of individuals or even for different individuals themselves, right? Okay, how do you think, Naveen Venugopal asks, how do you think females acquire certain ranks in a totally mixed up troop? I don't know what you mean by a totally mixed up troop, but I'll tell you what our Bandipur work shows. The problem with any Bonnet Macaque troop is once you go and start studying them, the female hierarchy has already been set, right? Because it's culturally there. You know who's A, who's B, who's C. So how was it originally set up when the troop was forming? We have no idea. But in Bandipur, in our long-term observations, we now see female emigration. Females are leaving groups, and sometimes females come from different corners and they establish a group together. And we've seen several instances of this, and it's fascinating how the hierarchy is originally set up. It is set up by priority of access. The first female who comes into a new area is alpha. The second female who comes is beta. The third female who comes is below her. They may challenge each other occasionally over food, but there is no serious threats to the hierarchy. And therefore, I think that this is the codified behavior. If I'm here before you, I'm dominant over you. As simple as that. It's a kind of a possession of a property kind of thing. If I'm the owner of this piece of land, then I'm dominant to you and you fit under me. However, and I don't have time to talk about it, there can be changes in the hierarchy even amongst females, though I did mention earlier that in general it doesn't happen. And that did happen in some of these cases, but maybe that's another story we should talk about. Yeah, I don't see any more questions here, I think, yeah.
Yeah, thank you, Ranada, for addressing all those questions. Though after looking at this flooding comment of disappointment about not to continue with your technical deception part, we request you to come once again, please, and deliver this talk in AIP platform.
Thank you.
And we are glad that
we
are able to get you in this short notice. So also we are thanking all those our audience who are continuously supporting us for last couple of weeks and always with us. And we have a small announcement as well. We are going to continue with our 7th talk about the Madagascar lemurs. The talk will be delivered by Dr. Tara Clark from North Carolina State University in 16th May at 6:30 p.m. Indian Standard Time. Thank you. Now we'll close our session with your permission.
Thank you. I think I couldn't address, I think, the questions that came on Facebook or YouTube, I think, right?
No, all those questions came to our Facebook. We also posted it here, and yeah, thankfully you were able to address all those things.
Thank you. Thank you very much, and thank you for being here for me.